Hello, in this video we're going to go over problem 25 from the 2024 University of Maryland High School Math Competition Part 1, which is a competition that I run every October. So here is the problem. An equilateral triangle T and a circle C are on the same plane. Suppose each side length of T is 6√3 and the radius of C is 2. The distance between the centers is 15 for every point x on T and point y on C. Let M of xy be the midpoint segment of the segment xy. Then we put together all of these M of xy's as x and y vary on C, and we get a region A. The question is, what is the area of this region? Okay, so let's draw a diagram and see what this region describes. So we have a circle of radius 2, they said. So let's say this circle is centered at the origin and the radius is 2. So the equation of the circle is x squared plus y squared equals 4, because the radius is 2. And then we have a triangle of the side, equilateral triangle of side 6√3. We take a point here. Let's call this point maybe A comma B. And then we take a point here. Let's say this point is x comma y. We look at the midpoint. Let's say this is C comma D. We want to see what is this point. What's the equation of this point? What does that point satisfy? So if we evaluate this point, C is going to be A plus x over 2, because that's the midpoint, and D is going to be y plus b over 2. So what we know is that x squared plus y squared equals 4, which means if I evaluate x, I get 2c minus a squared plus 2d minus b squared equals 4. So if I write this down in terms of c and d to see what c and d are, c minus a over 2 squared plus d minus b over 2 squared is equal to 1. So I divided both sides by 4. So what does this mean? It means c comma d is on a circle, on a unit circle. So c comma d lies on a unit circle centered at a over 2 comma b over 2. So I take the point A comma B and I evaluate A over 2, B over 2. So what is A over 2, B over 2? It means you're connecting it to the origin and you're looking at the midpoint of this. So if I connect something to the origin and divide it by 2, that's going to be the midpoint, which means the centers are going to be lines parallel to the sides of this triangle, and the length of these, the segments, the side length is going to be exactly half of what we had. And the regions are going to be a bunch of circles. So this is going to be the union of circles of radius 1 whose centers are on a triangle with side length exactly half of what we had, which would be 3√3. So this is the region that we are trying to find its area. So, okay, let's draw the region and let's find the area. So the region is going to look like this. We have a triangle and we're looking at a bunch of circles of radius 1. So we look at the radius 1. We look at every point that the distance between the sides of this triangle and that point is at most 1. So we look at these. At this point, you'll get a portion of a circle. At this point, you also get a portion of a circle. Here the same, and here you get some, I guess here I would have to look at a vertical line. So let me draw that a little bit better. So this would be a more correct drawing here. So I would get this one. This is a sector, and the angles here are 90 degrees, 90 degrees, and 60 degrees. So that angle is 120 degrees. And then I have a rectangle right here and a rectangle right here. So that diagram wasn't quite accurate. So I have three rectangles, and then I have three sectors here, and then we'll have to evaluate the area of these. Okay, let me mark what we have. So we have this rectangle, and this rectangle. We'll find those three rectangles. So these three rectangles are the area of the rectangles. The area of the rectangles is 3 times 3 root 3, which is 9 root 3. Now we need the three sectors. The three sectors are, each of them are a third of of a circle, because we have three sectors of central angle 120 degrees. So the area of the sectors, there are three sectors, is a whole circle. So it's pi r squared, and the radius is 1. Now we'll have to evaluate this region. Well, this region is, we can find the area of the triangles and subtract the two triangles. Well, if you look at the area of the larger triangle, so the base is, so 1/2 base is 3 root 3, and the height is, so if you look at the base and multiply it by root 3 over 2, you get the height. So it is 3 root 3 times root 3 over 2, which is going to be a quarter. 3 times 3, that's 9, times 3, 27, root 3. So area of a triangle, equilateral triangle, is root 3 over 4 times the side squared. And the area of the small triangle, we'll have to find the side length. So similar to what we had here, but we have to just find the side length. We know that this distance is 1, the perpendicular distance is 1, which means this one is root 3, and this one is also root 3, so the side length is root 3. So root 3 over 4 times the side length squared, which is 3 root 3 over 4. So now we can find the area of the region that they gave us. So it is 9 root 3, which are the three triangles, plus pi, plus 27 over 4 root 3, minus 3 root 3 over 4. So that is 9 root 3 plus pi, plus, this is 24 over 4, that's 6 root 3, and that is pi plus 15 root 3. And that is answer choice